This is a very important question on what we call the types of x-intercepts. But before we get into that, let's do a quick review on something we call the quadratic sequence. Now, if you have a quadratic situation, like y equals x squared minus 2x minus 35, and if you're asked for the x-intercepts mean that y is 0. So we can set the whole thing equal to 0, and that's our permission to factor. We're looking for two numbers that add to -2 and multiply to -35, and that would give us -7 and +5. So now we've factored a quadratic. Then we can use the zero product rule that says if those two parentheses multiply out to 0, that could only have happened if one of them actually were 0. So we said x minus 7 equals to 0, x plus 5 equals 0, and we solve both of those, and we'll get +7 and -5. So it flips the signs over. But basically, we're talking about how you can go from factors, which are the parentheses there, to roots, x-intercepts, solutions, and zeros. So these numbers at the bottom here, they have a bunch of different names and they're very important. But for the biggest purposes, we can call them our x-intercepts. So those are our x-intercepts right there. In my example, it was 7 and -5. So if I know that I have two solutions of 7 and -5, I can automatically say, well, the factors must have been x minus 7 and x plus 5. Or similarly, if we see something that looks like this, x minus 7, x plus 5 equals 0, then we can say, oh, well, we know that it hits the x-axis at 7 or at -5. In any case, looking here at this question here, we see that this is hitting at -5 and it's hitting at +4 in addition to hitting at 0. So those are our three x-intercepts. But like we said before, that doesn't tell the whole story. Let's just say we have on an xy axis a function that's going along, minding its own business, and then it crosses the x-axis and continues. Just crossing the street, crossing the x-axis, let's say that's the number 4 there, that would be like having a factor of x minus 4 to the first power. So it's simply crossing over, it's not doing anything special. On the other hand, let's say that our function is going around minding its own business and it decides to cross the street, but instead of crossing, it bounces off like a ball. That is a root to the second power, a double root. Last but not least, and a lot more rare on the SAT, but you never know. Let's say our function is going along, minding its own business, and when it crosses, it changes concavity, kind of like a sine curve. That would be a root to the third power. So we have the idea of a single root, a double root, or even a triple root. So we know that we're hitting the x-axis at -5, 0, and 4. So we know the factors have to be x plus 5, because we can't forget to flip the sign, x minus 4. And by the way, when you hit at x equals 0 for your x-intercept, that means that your factor in that situation is simply x. Just a little thing to kind of know, a little factoid that is important here, because we need to know that there is a factor of x at the very beginning. Now let's talk about what kinds of roots they are. Here at -5, the function bounced off the wall. That was our definition of a second root. So the factor of x plus 5 is the second power. At 0, it crossed over nice and simply, first power. And at x minus 4, which is x equals +4, it crossed the street there. So the one that bounced was this one right here. The other two just simply crossed the street. And so we have x to the first, x plus 5 to the second. So x to the first, x plus 5 to the second, and x minus 4 to the first. So answer choice B has all three of those.